Welcome to Lecture 1 on Module 1 of EE303 Linear Control Systems. Today we will be looking at open loop and closed loop systems. Let's go to the introduction. When a number of elements or components are connected in a sequence to perform a specific function, the group thus formed is called a system. So here we are defining what is a system. Now when do you call anything a system? Now if you are connecting some elements or components in a sequence such that it can perform a specific function, that is, you need to accomplish something, and to accomplish that you are connecting certain components or elements in a particular order. Now if by connecting them in that particular order can help you accomplish that particular function, then such a group is known as a system. Now there are a lot of systems available, but we are interested in one particular system where we can control the output by varying the input, and such a system is known as a control system. So a control system is any system whose output can be varied by varying the input signal. Now there are several names for the output signal. Few of them are as follows. Output quantity is also known as the controlled variable. Now the variable that is getting controlled, or it is known as the response of a system. And the input quantity is called the command signal or excitation. So if you take a system, if you give an excitation to that system, it produces a response. Or if you give a command signal to a system, it produces a controlled variable. Now we go on to specific control systems, and first of which is known as an open loop system. Now what is an open loop system? Any physical system which doesn't automatically correct the variation in its desired output is called an open loop system. So you know that why do we control a system? We want a particular output. Whatever we do, we want a specific output from that. Now that specific output for which we are controlling the system is known as the desired output. Naturally, there may be situations where you are not getting the desired output. There may be issues such as noises or disturbances in the system, such that you have a particular desired output that you want, but it is not giving that. Now if the system doesn't automatically correct itself so that it produces the desired output, then any such system is known as an open loop system. Now there is another way of saying this. Any control system in which the output quantity has no effect or influence upon the input quantity is called an open loop control system. Now what does this definition take into consideration? Here you can see that the output quantity is our desired output. Okay. Whereas if the output quantity varies, ideally that variation can be brought back to the desired output by varying the input. You know, in a control system you can vary the output by varying the input. Now if the output can somehow influence or affect the input, then a variation in the output can affect the input in such a way that it is brought back to the desired output. Now if any control system doesn't do that, that is, the output value has no effect or influence over the input quantity, then such a system is known as an open loop control system. Now this means that the output is not fed back to the input for corrections. Now one of the best examples of open loop system is a washing machine. Now when we are using a washing machine, you put in the clothes and you put in the washing powder and then you run it for a specific time. The thing that you have to notice is what is exactly the output that we want. What is the desired output? We want clean clothes. That is the desired output. Now how to know whether the system is an open loop system or a closed loop system? Does the input vary depending on the output? Is one way of checking whether the system is a closed loop system or an open loop system. Here the output that we want, the desired output, is cleanliness of the clothes, and the input is the time for which the washing machine is being run. Now does the washing machine extend its time if the clothes is not clean enough, or does the washing machine stop itself if the clothes have been cleaned? We know the answer, it doesn't. Hence the output, which is the cleanliness of the cloth, has nothing to do with how long the washing machine runs. So you can say that this is an open loop system. Now how do you make this open loop system into a closed loop system? For that we have to know what is a closed loop system, and we will explain this same example when we look into the closed loop system. Now let's continue with the open loop system for the time being. Thus we can say that if we want to correct the changes in the output in an open loop system, we have to manually control the input. That is, if you take the example of the washing machine, you can say that you have to check the cleanliness of the shirt, and if it is not clean enough, you may have to run it again. You may have to set the timer once again in the washing machine and clean it once more. So this diagram shows a typical open loop system. You can see that the output has no way to influence the input. We give an input to the process and it produces a corresponding output irrespective of whether the output has been achieved or not. Now we move on to a closed loop system. Any control system in which the output quantity has an effect or influence upon the input quantity in order to maintain the desired output value is called a closed loop control system. So what is a closed loop system? You can take the example of washing machine once again. If there is a washing machine which stops the washing machine once the desired cleanliness has been achieved, or if it runs as long as the dress is unclean, then you can say that that is a closed loop system, because the output that we want, the desired output, is a particular cleanliness of the dress, and if we set that output, and if the washing machine runs or varies the input, here the input is the time for which the washing machine is being run, if it varies the input such that it achieves the desired output, then such a system becomes a closed loop system. So if we have in some way to sense the cleanliness of the dress inside the washing machine, and if we feed that value, that sensed value, to the input such that it varies the input time until the desired cleanliness is achieved, the washing machine becomes a closed loop system. Now if you look at the diagram, this is one of the simplified ways of showing a closed loop system. You can see that there is a process which is also known as a plant, where here it is the washing machine. You can take, if it is an automated washing machine, it's a closed loop washing machine. Here the process is actually the plant or the washing machine, and the output that we said, was the cleanliness of the dress. Now the feedback is kind of the value that gets sensed, the cleanliness that gets sensed from the dress, and you can see that it is fed and it is compared with the value that we have set. Let's say that I've set the cleanliness of the dress to be 95%. Now it compares the cleanliness of the dress inside the washing machine, and it compares, let's say for the time being it is now clean 80%. Now that 80% is getting fed and it gets compared with 95%, and since there is a difference, that difference of value is being fed to a controller which converts that difference into the time for which the washing machine has to additionally run, and it runs the washing machine again, and this process continues until the cleanliness sensed by the feedback system becomes, say, 95%, where the error becomes 0, and when that error is being fed to the controller, it gives a signal for the washing machine to stop. So here the input is the value that we have set, the desired value that we have set, say 95%, and the output is the present output, that is the present cleanliness of the dress. Thus you can say that what did we actually do? An open loop system can be modified into a closed loop system by providing a feedback. That is what we exactly did. We provided a feedback which sensed the cleanliness of the dress. Now the provision of feedback automatically corrects the changes in the output due to disturbances. Here what we are saying is the disturbances means the variation from the desired output. So the desired output was 95%. When you put in the dress, it will have a cleanliness, say about 40%. Now there is a variation from the desired output, and that variation is provided to the system through the feedback so that it automatically corrects. Hence a closed loop system is also known as an automatic control system. Now this is a detailed explanation of the closed loop system. You can see that there are various ways in which we can call this. We'll start with this, the reference input R of t, that is the desired value, or it is also known as a set point. Then there is a comparator, which is also known as an error detector. Then there is an error signal. Then there is a controller which has a power input. Then there is a system and the disturbances, and the controlled variable or the output is produced. So let's start with the controlled variable or the output. Now what will be the output? That is being fed into the measuring means or the sensors, and that value is being sent to a comparator or an error detector. Now at this comparator or the error detector, the desired value, the value that we want, gets compared with the actual value or the present value of the output. Now if the desired value is larger, or if the output, the current present value, is lesser than the desired value, the difference between them, that is desired value minus the current value, becomes a positive value, and that positive value is sent to the controller in the form of an error signal. This controller has the function of converting this error signal into a type of signal which is acceptable by the system. Moreover, it also amplifies the error signal so that it can be sensed by the system. Now what if the output is larger than the input? This can be explained by explaining the cruise control of a car, that I'll explain when we go to the examples. Now there may be situations where the output value is actually larger than the desired value. then the error signal will become negative, and correspondingly the controller will give a signal to the system to change the current working condition. So in such a system you can see that there are two loops. One is the forward loop and the other is the feedback loop. Now through the forward loop and the feedback loop, the system maintains itself by making sure that the output C of t is equal to the reference input R of t. Now if such a system maintains that, it is known as a closed loop system. The same points are being explained here. You can see that in the second point, the feedback path elements measures the output and converts it to a signal of same type as that of the reference signal. That is the additional function of the feedback path elements. That is, one is to sense the output and second is to convert that output into a form which is similar to that of the reference signal or the desired value. I've explained this already. Now let's look at the advantages and disadvantages. We look into the advantages of an open loop system. Now why, if the open loop system doesn't correct itself, why do we still opt for open loop system? The open loop systems are simple and economical. That means there is no much cost involved to produce an open loop system, and construction wise also it is very much easier to construct an open loop system when compared to a closed loop system. Now moreover, an open loop system is stable in general. So due to these advantages, people still opt for open loop systems. Now open loop system has their disadvantages also. Now, one of the disadvantages is that open loop systems are inaccurate and unreliable, because if due to some external influences the output changes, we have to manually control the input to bring it back to the desired value. Moreover, whatever be the output value can be unreliable or inaccurate, because we may not know if there has been any influence of the noise or disturbances in the output. Now due to these disadvantages, we generally opt for a closed loop system. A closed loop system has the following advantages. Closed loop systems are accurate, they are less affected by noise, and the sensitivity of the closed loop systems may be made small to make it more stable. Now why the third point is mentioned? Because in general, when compared with open loop systems, closed loop systems are less stable. Moreover, since we have to provide sensors and feedback path, closed loop systems are complex as well as costly. Now when we provide a feedback, there is also a possibility that an oscillatory response can occur. Now this issue doesn't occur if it is an open loop system. Now let's look at few examples. Microwave oven. I'll say what is the input and what is the desired output and how it becomes an open loop system. Now for a microwave oven, the desired output is a specific point to which the food has to be cooked. Okay, and the input is the timer that we set in the microwave oven. We know that when we set a time in the microwave oven, whether the food gets cooked or not, which is the desired output, the timer will go off and the microwave oven will turn off. So the output, which is the desired point to which the food has to be cooked, has no influence on the input, which is the time for which the microwave oven is on. Hence this becomes an open loop system. Now let's look at the sprinkler system. in a sprinkler system, the desired output is the particular degree of wetness of the surface, and the input is the supply of the water. Now let's take an example where you turn on the sprinkler and it's raining. Now if it had been raining, the output, the desired output, that is a particular wetness of the ground, has already been achieved. But irrespective of that, the sprinkler will continue to work, which means that the output, the desired output, which is the degree of wetness of the ground, has no influence on the input, which is the supply of the water. And you can say that a sprinkler system is an open loop system. Third one is traffic control. Now a traffic light has a particular time set when it turns from red to green or vice versa. Now the desired output is, what is the desired output of a traffic control? To make sure that the road in which the traffic control is provided must be rush free. I mean, you have to make sure that all the vehicles flow smoothly through the road. Now if it's a high rush hour, if it had been a closed loop system, it would run the timer even more than 60 seconds until all the vehicles go away. But we have seen that even if there is one or two vehicles, or if there are hundreds of vehicles, it will still go off maybe for a 60 seconds or 120 seconds for whatever time it has been set. It means that the output, desired output, which is smooth flow of the traffic, has no influence over the input, which is the time for which the traffic light has been set. Hence you can say that this is also an example of an open loop system. Now let's look at few examples of closed loop system. Here the desired output is the temperature of the surface of the iron box, and the input is the supply into the iron box. You can see that when the temperature has been met, it cuts off the supply, and once you use that iron box, and if the temperature falls beyond a particular temperature, it automatically turns on. The desired output, which is the particular temperature of the surface of the iron box, determines when to turn on the supply or when to cut off the supply to the iron box, which means that the output has an influence on the input, and thus we can say that an iron box is a closed loop system. Now second is an air conditioner. That is, if you set an air conditioner say to 24 degrees Celsius, it will send in cool air probably to maintain the temperature at 24 degrees Celsius. Now if it is a hot summer day and if you open the windows, you can assume that hot air will come into the room and the temperature invariably changes. Now what happens? The air conditioner will try and pump in even more cooler air so that the temperature again falls to 24 degrees Celsius. So here the input, which is the supply of the cool air, is being influenced by the output, that is the temperature of the room. Hence you can say that an air conditioner is an example of a closed loop system. Now the third one for the closed loop system is cruise control in vehicles. Now cruise control is a feature where you set the speed of the vehicle to a particular value, let's say 60 kilometers per hour. Now once you set to that speed, the vehicle has to move at 60 kilometers per hour even if it is moving uphill or downhill. Now this is an example where the output value can be more than the desired value. If it is going downhill, it can invariably increase its speed beyond 60 kilometers per hour. Now what happens if it goes beyond 60 kilometers per hour? That is sensed by the car and it will adjust the fuel injection and the application of brakes such that the speed reduces and comes back to 60 kilometers per hour. Whereas if it is moving uphill, the tendency is to slow down and it will adjust the fuel injection or acceleration so that the velocity is again brought up to 60 kilometers per hour. Thus you can say that the output, the desired output, that is running the vehicle at 60 kilometers per hour, influences the input, that is fuel injection. Hence this system is also an example of a closed loop system. Now with this we end this lecture.